In this lecture we will see the solid oxide fuel cells, their constructional features mainly, along with its working. So if you see here in this type of fuel cells, we have anode outside and cathode inside, which is in the green color, and in between we have electrolyte, which is of solid electrolyte. So the electrolyte is not liquid here, it is of solid type, usually of a ceramic type, positioned between anode and cathode. And fuel is delivered to the anode, and oxidant, that is oxygen, is delivered to the cathode. That means delivered means it is given to the cathode, right? So oxygen is given to the cathode. Here it is shown in red color, anode is shown in green color, and the fuel is delivered or given to the anode, right? In between we have electrolyte, right? And the chemical reaction, the net chemical reaction is given here. 2H2 plus O2 gives rise to 2 molecules of water along with 2 electrons. Okay, so in the electrolyte here, the positive ion is moving from anode to cathode, whereas negative ions are moving from cathode to anode. So the electrons that are getting generated at the interface of anode and electrolyte, due to the interaction between hydrogen as well as oxygen that is reaching the interface, will be traveling from anode to cathode through the load, right? So of course the depleted fuel and the product gases will be coming out from downwards here, and towards the cathode side depleted oxidant as well as product gases will be coming out from downside. So here we are talking about oxidation and all, but what is this oxidation? The oxidation generally refers to the loss of electrons by a substance. So when a substance undergoes oxidation, it becomes more positively charged because it has lost negatively charged electrons. So due to the oxidation process, the electrons will be lost, so the substance becomes positively charged. So when some energy of negative charge is lost, what happens? It becomes positively charged. So the main features of these solid oxide fuel cells are, there will be interconnects which will be connecting the cells, and there will be sealings. The seals will be preventing the leakage, and current collectors will be there to gather electrical current, and support structures will be maintaining integrity, while insulation minimizes the heat loss for efficient operation. All these are some constructional features of SOFCs. So as I said, the electrodes are of solid type and they are porous structures which allow the fuel and air to diffuse to the electrolyte, and the products of the electrochemical reaction on the anode side to be diffused away from the electrolyte, right? And the electrolyte conducts the oxygen ions formed by the electrochemical reduction of molecular oxygen from the cathode side to the anode side. So the fuel which is diffused through the anode to the interface of anode and electrolyte will be reacting catalytically with the oxygen ions and releasing electrons, which will be transported through the external circuit, right? So here we need to change this sentence. Fuel diffuses through the anode to the anode electrolyte interface and reacts catalytically with the oxygen ions for releasing the electrons that are transported through an electrical circuit, right? So this is for producing electricity, no need to mention here. Fine. Okay, what are the advantages of this type of fuel cells? The advantages are high combined heat and power efficiency, long-term stability, fuel flexibility, low emissions, and relatively low cost. Coming to the disadvantages, the high operating temperature will be resulting in longer startup times, and mechanical and chemical compatibility issues will be there, right? This is all about solid oxide fuel cells, right? That's it.